Oh, hi. It is 80s day at school today. So you get me like this, and I hope you have a bright and happy day. So we are going to work on lesson 2-3 today. There's no spark, so we are just going to jump right in. You are going to want a paper and a pencil to do some problems with me and do some practice so that you are able to do this and then do your homework tomorrow. So today we are going to work on finding the greatest common factor, otherwise known as GCF, and we're going to find the least common multiple, which is known as the LCM. So those are just the abbreviations, GCF, LCM. So we're going to talk about what those mean and how to find them today. So this first problem here says that we have 3 runners that leave the starting line at the same time. Lena runs each lap in 3 minutes. Aria runs each lap in 5 minutes, and Tran runs each lap in 6 minutes. When is the first time in minutes that all 3 runners will cross the starting line together? So they're just running laps around, but they're all running at different rates. So we want to know, when are they going to all sync up and be running together for just a second again? So to do that, we are going to find the least common multiple, the LCM. So we know multiples mean more. So connect those words together. Multiple, more, go together. So we are looking for products of another number of that. And so it's like timesing. So if we're making multiples of 4, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So 4, 8, 12. So all the products of a number. So if you're skip counting is another way to think of that. So we're going to start and look at a problem here. Let me get to the start of my work here. So the LCM, least common multiple. We want the lowest number that they have in common. That's a multiple. So we are going to list out multiples of these numbers. So if I am starting with 12, if I take 12 and times it by 2, I get 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. 12 times 6 is 72. So I'm going to stop there and see if that's enough. I might have to add more if I haven't gone far enough. So now I'm going to list the multiples of 20. So skip counting by 20, then 40, 60, and I can actually stop there because I see that these are in common. So it's the smallest number that they have in common. So they don't both have 40. They do not both have 20. So the smallest number they have in common is 60. So grab your paper and pencil and go ahead and list the multiples of 8 and 12. Pause the video and then come back and check. Okay, so if I'm listing out multiples of 8, I've got 8, 16, 24, 32, 40. Okay, I'll try that. Hey, now I'm looking for 12. So 12, 24. Oh, I can see right there they have 24 in common. So their least common multiple is 24. Okay, go ahead and list out the multiples for 4 and 9. So pause the video, try that out, and then come back and check your work. Okay, so here we have 4, 8, 12, 16, 20, 24, 28. Gotta make a new line here. 32, 36, 40. Okay, let's try that out here. So I'm going to list 9, 18, 27, 36. So I can see they do not have 9 in common. They do not both have 18. They do not have 27, but they do have 36. So that least common multiple is 36. 6. So let's go ahead and try task 1 here back in Ed. Here asks, how many minutes does it take Lena to run 12 laps? If you drop these down, these are just numbers you may have typed in before. I was super confused at first. I was like, those are not the right answers. Like, that doesn't even make sense. So if you are seeing drop down stuff, that's just numbers you've typed before. Those are not the answers. I was like, 70, where's that number coming from? Okay, so we need to know how many minutes it takes Lena to run 1 lap. So if I look up here, Lena runs each lap in 3 minutes. So I want to know, that's for 1 lap. We want to know 12 laps, and every lap is 3 minutes per lap. So 12 times 3 is 36. Then you should have it right. So make sure you type numbers in. I thought I had to drop it down and was very confused there. Okay, so now we are going to complete these charts here, and we're going to do that skip counting. So 3, 6, 9, 12. If you don't know your 3s or your 5s or your 6s that are on this chart, all you have to do is count. So 3, 4, 5, 6, 6, 7, 8, 9, 9, 10, 11, 12, 12, 13, 14, 15. So you all have fingers, so use them. They're a tool you have that's always with you. So I don't care if you use your fingers. I use my fingers still too to make sure I get the right answer sometimes. So go ahead and pause and fill out all of these skip counting. Hey, so C asks us to look at the results from our table, and we're going to look for a pattern we notice about the times in each column. So looking here, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And then over here, 5, 10, 15, 20, 25, 6, 12, 18, 24. I know when I'm saying those, that those are multiples of those numbers. Skip counting is the same thing as multiples. We're multiplying. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. We're multiplying. Multiples are more because we multiply them. So now we're going to choose a sentence about the runners' times, the 3 runners' times that is true. So the 3 runners have a time of 6 minutes in common. So this one has a 6, but I know when I count by 5, I don't say 6, and 6 has a 6. So I know the first one's not true. The 3 runners have a time of 15 minutes in common. 3, 6, 9, 12, 15, yes. 5, 10, 15, yes. 6, 12, 18. Nope, that one's not true. So now the 3 runners have a time of 30 minutes in common. Let's check and see. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That one sounds good. 5, 10, 15, 20, 25, 30. 6, 12, 18, 24, 30. So they all have 30 minutes in common. So the LCM for 3, 5, and 6 is 30 minutes. So after they have been running for 30 minutes, they're all going to sync back up and cross the finish line or the starting line together. And it's not true that they have no time in common. They did have 30 minutes in common. So what is the least common multiple? Well, we just figured out the lowest number that they all have in common is 30. So is the least common multiple of numbers in order from least to greatest. So we know 3 was the smallest number, 5 was our next one, and 6. So 30 is the least common multiple of 3, 5, and 6. Okay, so go ahead, and this is asking if you extended the table, that means added to it, what would the next common multiple be? So if they ran 11 laps, tell me what would 3, how many minutes for 3, for 5, and for the 6 for your turn and talk there. Let's go ahead and pause and do that. Oh, and then also make sure to tell me about patterns other patterns you notice? Hey, task 2 is talking about some granola bars and some water bottles. Here's 24 granola bars, 16 water bottles. So Taylor and Jake are in charge of bringing snacks for their chess club. They have 24 granola bars and 16 water bottles, and they're going to set out the snacks so that the snacks are distributed evenly into snack packs with no granola bars or water bottles left over. So they're putting the granola bars into groups and the water bottles into groups as well. What is the greatest number of snack packs that Taylor and Jake can make? So this is where we are going to look for our greatest common factor. So factors are numbers that are fewer than the number we're looking at. So if I have the number 12, the factors of 12 are 3 and 4. 3 times 4 is 12. So we're looking for the greatest common factor. So let's take a look at that a little bit closer here. So make sure you have out your paper and your pencil. In a minute, we're going to be doing some work here. So the word greatest means we want the biggest number. In common means that it's shared. And a factor is a number that when we multiply by another one equals something else. So we are looking for the largest factor they have in common, the greatest common factor, or the GCF. So when I'm finding the GCF, one strategy you can use is to make a list of factors. And I always like to start with 1 times the number. And then I ask myself, can 2 go in there? Yes, because it's even, 2 times 24. I ask myself, can 3? Well, 4 plus 8 is 12, and I know 3 goes into 12, so I know 3 goes in there. Goes in there 16 times. You can do a division problem if you are not sure, and you can solve that, and that equals 16. 4 goes in there 12 times. I ask myself, can 5? No, because it doesn't end in 0 or 5. Can 6 go in there? Yes, 8 times. Can 7? No. And then I have 8, so I know those are all of the factors of 48. So these are pairs that are lined up across from each other. So now I ask myself for 24, 1 times 24. Can 2? Yes, 2 times 12. Can 3? Yes, 3 times 8. Can 4? Yes, 4 times 6. Can 5? No. And I already have 6, so there's all the factors for 24. And then 32, we have 1 times 32. There's always going to be 1 and the number. 2 times 16, 4 times 8. So 3 can't go in there, 5 can't, 6 can't, 7 can't, and I already have 8. So here are all of the factors for 48, 24, and 32. So now we want to look for the greatest factor that they all have in common. So I can see they don't all have 48 here. Here's 24 and 24, but 24 is not a factor of 32. Here's 16, no 16 here, so it can't be 16. 12, 12, oh, no 12 over there, it can't be 12. 8, 8, 8. Oh, they all have 8. So 8 is the greatest common factor for 48, 24, and 32. So notice I started looking at the biggest number because I want the greatest number. So it makes sense to work backwards to find the biggest number they have in common. So let's try some of those out. So we're going to actually skip that one for now. So will you pause and see if you can list the 3 factor pairs for 18 and the 4 factor pairs for 30, and then see if you can find the greatest number they have in common. So come back and check when you are ready. So I ask myself, can 1? Yes, 1 and 18. Can 2? Yes, it's even, 2 times 9. Can 3? Yes, 3 times 6. Can 4? No. Can 5? No. And I already have 6. So I know I have all of the pairs. Then for 30, I have 1 times 30 always. Can 2? Yes, it's even. 2 times 15. Can 3? Yes. 3 times 10, can 4? No. Can 5? Yes. 5 times 6, and there's 6. So now we're looking for the greatest common factor. Do they both have 18? No. Do they both have 9? No. Do they both have 6? Yes, they do. So the GCF of 18 and 30 is 6. Hey, let's try another one here. So go ahead and list the factors for 7 and for 28. So pause the video, find the GCF, and come back and check. Okay, so 7 has 1 and 7. 2 can't go in there. 3 can't. 4 can't. 5 can't. 6 can't. So 7 is a prime number. The only factors that it has are 1 and itself. And 28 has 1 and 28. 2 can because it's even. 2 and 14. 3 can't. 4 can. 4 times 7. 5 can't. 6 can't. There's 7. So I know I'm done. So I'm looking for the largest number they have in common. 7. They both have 7. So 7 is the largest number they both have in common. So sometimes one of the products can go into the other, and that can be your greatest common factor. Okay, so we're going to try a harder one now. So you're going to pause and list all of the factors for 40, for 60, and for 24 and see if you can find their GCF. So go ahead and do that and come back and check. Hey, 40 has 1 and 40, 2 and 20. I know 3 can't, 4 and 10, 5 and 8, 6 can't, 7 can't. There's 8. So I know I'm done. Hey, 60 has 6 pairs of factors. Were you able to get them all? So 1 and 60, 2 and 30, 3 and 20, 4 and 15. That's one a lot of people usually forget. 5 and 12, and 6 and 10. That one is not popping up like my other one. So 6 and 10 there. Hey, 24 has 1 and 24, 2 and 12, 3 and 8, 4 and 6. So I'm looking for the greatest number they have in common. So I know that on 24, the biggest number is 24. So there's no way it could possibly be 60. And there's no way it could even be 40. So I'm going to use the smallest number and go backwards on its list to check. So do they each have 24? Nope. Do they each have 12? 12? Oh, no, 12 there. Do they each have 8? Oh, no, 8. So it's not 8. Do they each have 6? And 6? Oh, no 6 there. So now I'm going to go to the next number, which is 4. Here's a 4, 4, 4. So their GCF is 4. Hey, so that's a lot of work sometimes, and it can be easy to make mistakes like on the number 60 when we're trying to list all of the factors. So here is another way that you can find factors. It's called using a factor tree. So we're going to take a look. So what we're trying to do is we are trying to find the prime numbers. So prime numbers are things like 2, 3, 5, 7, 11, 13. Those are the first 6 prime numbers. The only numbers that can make them are 1 times 2, 1 times 3, 1 times 5, 1 times 7, 1 times 11, 1 times 13. They do not have any other whole number factors. So we are going to start, and we get to pick any numbers that we know make 60. So I'm going to start with 6 and 10. You just pick any ones you know. I'm actually going to do another problem over here of 60, and I'm going to pick something different that equals 60, and we'll see how our answers turn out. So I'm going to pick 4 and 15 here. So 6 is not on my list, so I need to keep going. So 2 times 3 is 6. So the numbers 2 and 3 are on this list down here. So I'm actually going to put a box around them to say these numbers are done. So the number 10, to get 10, I would times 2 and 5. Well, those are both also prime numbers. So I put a box around them. So be sure you're doing this with me on your paper to practice. So 2, 3, 2, and 5 are these prime numbers. So let's try doing 60 a different way and see what answer we get. So the factors to make 4 are 2 and 2 is a prime number. So I box them up to say those are done. And then to make 15, I have 3 and 5, and those are both prime numbers. So I'm going to box those up as well. So I can see here 2, 2, 3, 5. Here's 2, 2, 3, 5. So even doing 60 a different way, I came up with the same prime numbers. Okay, so let me get this out of the way here. And let's try this number 81. So go ahead and think of two numbers you can multiply together that equal 81. So I thought of 9 times 9. 9 is not a prime number. There's more factors I can break it down to. 3 and 3. Now 3 is a prime number, so I can box those up. And same thing here. 3 times 3 is 9. Box them up. Now all the numbers across the bottom are boxed up. So what we're going to do now is we're going to look for any numbers that are in the boxes that are matched up. So here's a 2. Do we have a 2 over? And it has to be in the opposite problem. So I know there's a 2 in the 60, but it has to be from the other problem. So there's no 2 over here. So I do not need my 2's. 3, 3. There is a 3 in both of them. So I'm just going to write it down below. And I've used that. So that one's done and that one's done. So we have a 5 over on both sides. We do not. So even though there are more 3's, they're not in opposite problems. So we can't use them. They are not helpful to us right now. So the GCF of 60 and 81 is 3. So rather than having to list out all of the factors for 60 and all of the factors for 81, you just do a couple problems and you see what they have in common. If they have more than one number in common, so let's say it had a 2 in common and it had a 3, you just multiply those and that would be your GCF. So let's try another one of those. Okay, 72 and 108. So 72, let's make sure you're writing these down with me to practice. So I know 8 times 9 is 72. So down here, I'm just going to list those prime numbers, 2, 3, 5, 7, 11, 13. So those are the main numbers that I'm looking for. There are many other prime numbers that can keep on going, but we're trying to pretty much get it down to these smallest prime numbers. So I know 8 has more factors. 2 times 4 is 8. 2 is prime, but 4 has more factors. 2 times 2. So I'm going to box those 2's up there. So my 8 is all done. Everything is boxed up. To make 9 is 3 times 3. 3 is a prime number, so I'm going to box those up. Okay, so the number 108, that's a fairly large number, and I don't know all of its factor pairs. I don't even know how many factor pairs it has. Probably quite a few. It's an even number, it's pretty big, so that'd be kind of a lot of work to figure those all out. So instead, I can just think of two things that equal 108. So I know this number is even. So I know 2 has to go in there. So I can't think of some things off the top of my head that equal 108, but I know 2 goes in there. So then I can take 108 and I can just quickly divide it. 2 goes into 10 5 times and 2 goes into 8 4 times. So my other factor is 54. That's a much better number to work with. So my 2 is done. Look at that. So let's do this 54. We need to think of 2 factors that together multiplied equal 54, 6 and 9. 6 times 9 is 54. So I need to keep going on 6. 2 times 3 is 6. And then I'm going to box those up. And then 9 has 3 times 3. And now 3 is prime, and I can box those up. So all of the bottom numbers are boxed. So now we're going to look and compare and see what numbers we have in common. So 2 and a 2. So yes, I'm going to write that down. Hey, here's a 2. Here's another 2. So I'm going to write the next 2 down. Here's a 2. Do we have one over here? Nope. So I can't use that one. So now let's look for a 3. Oh, here's a matching 3. Let's write that down. And here's a 3. And here's a 3. So we do have this last 3 left over, but there's not another one to match it up. They each have to have their own match. So now we're going to do 2 times 2 times 3 times 3, and that is going to tell us our GCF. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So the number 36 goes into 108 is what that means. And it also goes into 72. So the biggest factor that goes into 72 and 108 is 36. Okay, so there's a couple different strategies you can use to find the GCF. You can either make a list, or you can use the factor tree and find the prime factors, match them up, and multiply any matches. Okay, let's go take a look at task 2 now. Okay, so Taylor and Jake have these 24 granola bars and 16 water bottles. So they're trying to put them into groups and have nothing left over. So here we're going to say if we only had one group, this is kind of like making our factor pairs in our list. We would have 24 granola bars. If we had 2 groups, 2 times what is 24? 2 times 12. If we had 3 groups, 3 times what is 24? 8. Okay, so this one is saying if we have 6 in each group, how many groups? So 6 times what is 24? 6 times 4. Hey, I want you to pause and see if you can finish. So 4 times what is 24? 8 times what is 24? 12 times what is 24? And 1 times what is 24? So every time we're trying to make 24 when we multiply. Hey, then we are going to do the water bottles here. So 1 times 16, one group would have 16 water bottles. 2 groups, 2 times 8 is 16. So now you're going to do the same thing for the water bottles. 4 times what is 16? 2 times what is 16? And 16 times what is 16? So go ahead and pause if you need to finish those charts. Hey, so in the first table, the number of snack packs and the number of granola bars per pack are factors of, so in this first one, everything when you multiply together equals what? When we multiply across, what is the product of that? And then in the second table, when we multiply across, what is the product of that? Use the information from the tables to list all possible numbers of snack packs for each item. So what we are going to do is we are going to say that you could have 1 granola bar here. So I could also have a pack of 2 times 12, and I could have 2 granola bars in a pack. So pretty much you're just taking this list and putting it from least to greatest, and you'll do the water bottles least to greatest there as well. So now you're going to take a look at your list, and you're going to look for any numbers that they have in common. And you're going to check all of the numbers that are shared with the granola bars and the water bottles. So now the greatest number that you checked was the GCF. So the greatest number, you'll type it in here, was, and the biggest number that they both had on their list. So the greatest common factor, so same number, the greatest common factor is, type it there. Okay, then part F says that we can also use the distributive property here to write these problems and figure this out. So we have 24 and 16 as a sum of our products. So I do one group of 24, the answer is 24. I do two groups of 12, the answer is 24. So it's saying if I add my granola bars and my water bottles together, we're trying to figure out how many there are. So we know the greatest common factor was 8. So they pulled out that factor of 8. So 8 times what is 24? 8 times 3 is 24. And 8 times what is 16? 8 times 2 is 16. So this is just another way to think about it. We're pulling that number out that they have in common. And we're saying that 8 times 3 is 24. 8 times 2 is 16. 24 plus 16 is 40. So we could write this another way. So we could also put the 2 and the 3 together first. And we could say that 8 plus 2 is 5. 8 times 5 is 40. So just another way to kind of think and pull out that greatest common factor there. Okay. All right, task 3 is going to ask us which is greater, 5/6 or 7/10. So we're going to enter the missing multiples for each denominator in order from least to greatest. So we're trying to make a common denominator here. So out of 6 and 10, you're going to list your 6's, and this one is a typo. This should be 36. So just ignore that one. So 6, 18, 30, 36. So see if you can fill in those skip counting blanks. And then we have 10, 20. See if you can fill in those blanks. And now you're going to find the smallest number that they have in common. Then we are going to rewrite our fractions using that LCM. So if I am looking at my list of 6, 12, 18, 24, 30, 36, 10, 20, 30, 40, I can see the smallest number they have in common is 30. So I want to rewrite these fractions with 30 as the denominator. So how do you get from 6 to 30? Times by 5. Whatever you do to the bottom, you have to do to the top. So 5 times 5 is 25. So my answer is 25 over 30. Times by 5, times by 5. So now we want to make 10 have a common denominator of 30 as well. So I ask myself, how did I get from 10 to 30? I times by 3. So I do the same thing to the top. 7 times 3 is 21. So 21 over 30 are my two new fractions. Now I can compare them a lot easier. So I know if we have, these are just fractions. Let's say that this was a pan of brownies and there's 2 pans of brownies. One had 5/6 of it left, one had 7/10. So if we cut them all into the same amount of size of pieces, which would be 30, one pan has 25 in it and one pan has 21 in it. So I know the pan with 25 has more. So we're going to write an inequality. So remember, that's our comparing symbol. An inequality, it even tells me right here, to compare. So 25/30ths, I know is greater than 21/30ths. I've got 4 extra brownies than in this pan. So that also means 25/30ths was the same thing as 5/6. So that means 5/6 is greater than 7/10 as well. Okay, so when we're comparing fractions, the easiest way is to make them have a common denominator. So let's take a look at a negative one here. So 13/24 and 7/18. So we're going to do a little work here. So first, we need to find the LCM of 24 and 18. So we're going to list out multiples of 24. So 24, and I don't know about you guys, but I don't know my 24 multiplication facts off the top of my head. So we might have to do a little bit of work, and that's okay. So 24 plus 24 is 48. So my next multiple is 48. Then I'm going to add on 24 more. 8 plus 4 is 12. There's 5, 6, 7 is 72. Let's go one more to make sure we have enough. That was a bad 7, 72. There we go. 24 more makes that 96. So let's see if 18 has any of those in common or if we need to go a little bit farther. So I know my first one, 1 times 18 is 18. That one's always easy. So I'm going to come over here and add. So go ahead and add 18 plus 18 with me. So 8 plus 8 is 16. 1, 2, 3, 36. Nope, I've got to keep going. No 36. So add 18 more. 6 plus 8 is 14. 3, 4, 5, 54. Oh, I've got to keep going. No 54. Okay, so here's my next group of 18. 4 plus 8 is 12. 5, 6, 7, 72. Do I have a 72 up here? Oh, yes, I do. So I can stop there. So I know that my least common multiple is 72. So that is going to be their common multiple or their common denominator. So now we're going to create equivalent fractions using that number of 72. So I'm going to write out here, so make sure you're writing this down with me to practice. So 13/24, and I need to make it into a fraction with 72. And I also need to remember that these are negative numbers. So how did I get from 24 to 72? I'm going to come back and look at my list. It took me 1, 2, 3 times. So I'm going to times by 3 here. That means I need to do the same thing here. So go ahead and do 13 times 3, and that's your new numerator up here. Hey, now let's try negative 7/18, and we need to make it into negative 72. So first I need to know how many times it took me to get from 8 to 72. So, sorry, 18. 1, 2, 3, 4 times. So that means I had to do 18 times 4 is 72. Whatever I do to the bottom, I need to do to the top. So 7 times 4 is 28. So I have these new fractions. So let's double check this one that you should have already done. So 13 times 3, 3 times 3 is 9. 3 times 1 is 3. So I have negative 39 over 27 and negative 28 over, sorry, not 27, 72 and negative 28 over 72. So let's go ahead and use our new fractions. I'm just going to write them down. So 39 over 72 and negative, oh, it left me 28 over 72. So I'm going to think about these for a second like they're positive. And I know they're both, well, negative 528 over 72. I know half of 72 is 36. So that means this one is a little bit smaller than a half if I were doing positive numbers. I'm going to just think about them positive for just a second. And this one's just a little bit bigger than a half. So if I had 72 in my whole thing, and I had 39 out of those pieces. 39 is greater than 28. So now I'm going to take that and graph the opposite of these to help me think about that. So that means this one is not quite to the 1/2, negative 28 out of 72. And then this one is going to be on the other side of the negative half, negative 39 out of 72. So I know the one farther to the right is going to be greater. So even though 28 sounds smaller than 39, we're talking about those negative numbers here. And so it is going to be bigger. You could also think about it, right? If you're right here at 0 and you're looking out into the distance, 28 is closer to you, so it's going to look bigger than the number 39 down here. So if you're looking far away, this one's going to appear closer than this one. So think about those negative numbers are going to be backwards. The farther to the right, the bigger it is. So let's go ahead and finish that task 4 here. So we've done all the work. So go ahead and list out your multiples of those numbers. You've already done that work with me. Tell me their least common multiple. Then you're going to tell me your new fractions that we made and compare them using our new fractions and compare them using the old fractions. So connect. So we said that negative 28 over 72 was greater. So connect which one was 20, which one equaled negative 28, which was 7/18. So that means that negative 7/18 is greater than negative 13/24. So, and then, so you compare those original fractions. So how do we compare? How could we compare using 1/2, which is pretty much what we did before? So half of 18 is 9 divided by 2. 18 divided by 2 is 9. 7 is less than 9, so I know that 7/18 is less than 1/2. And half of 24, if I divide that by 2, is 12. 13 is bigger than 12, so I know that this is bigger than 1/2. So, and remember these are negatives though, so the one farther to the right is still that 7/18 is greater than negative 13/24. So remember when we're doing negatives, think about where are they on that number line. Hey, thanks for hanging in there today. I know that one was a little longer than normal, but lots of information to learn today. So I hope you did that with me. So go ahead and do your check for understanding. And that is all for today. Okay, see you guys tomorrow.